Number 17, solving algebraically, we want to make sure we get a common denominator, x plus 7 minus x plus 7 over x plus 7. When is that greater than 0? Well, make sure you're careful here. We're going to subtract the entire numerator, x plus 7. Combining the fractions, we just like if we had 4 sevenths minus 1 seventh, we would write it as 4 minus 1 over 7. So just to remind you how we add fractions, we don't do anything any differently when we're adding fractions that are more complicated. We still remain, we keep the same, oops, that's going to be a 3. We keep the same format. It's the same concept. If the denominators are the same, 4 sevenths minus 1 seventh is 4 minus 1, or 3 sevenths. 4 sevenths minus 1 seventh is 3 sevenths. Well, this over x plus 7 minus this over x plus 7 is the x plus 3 minus x plus 7. So then when we distribute this minus sign, you got to be careful about that. X minus x is 0. 3 minus 7 is negative 4. So we get negative 4 over x plus 7 is greater than 0. So when is that greater than 0? Well, we have to set up a sign chart. And because our denominator's sign is changing, and the only critical number on our sign chart is negative 7, because that's where the denominator changes from when you move from the left of negative 7 to the right of negative 7. The denominator changes sign, meaning that if we look at the numerator is always negative 4. The denominator then to the left of negative 7 is going to be, so negative 8, negative 9, negative 10. You can see the denominator is going to be negative. So therefore, the fraction's value is always going to be positive. Positive is a good thing. So when you're looking right there, you look at that sign, you know that, oh, all these real numbers from negative infinity to negative 7 are going to make the left side positive, and that's what we want. We want all the real numbers that make this statement true. In other words, that all these numbers that make this statement true are going to be the real numbers that make the original statement true. So that's why we do the sign chart. That's why we get it down to one fraction, so we can analyze the signs. Likewise, though, to the right of negative 7, the numerator remains negative because it's negative 4. But when you replace x in the denominator with a number that's greater than negative 7, so like negative 6, negative 5, 0, any of those numbers, the denominator is positive. Therefore, you're going to have a negative divided by a positive, which is going to be a negative. Now, so any real number to the right of negative 7, so from negative 7 all the way to infinity, all of these real numbers make this fraction equal to a negative number, and that would not make this a true statement. So therefore, the answer to the question, solving the inequality, all the real numbers, the solution is all the real numbers to the left of negative 7, and not including negative 7, because negative 7 is not a member of the domain, because it makes the denominator equal to 0. So that's the solution.